Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your types of the sweeteners. Okay, so in this lecture we are going to focus on which like a type of the sweetener that we use in a industrial level. So traditionally we all know that the sugar that is your sucrose or honey, they are used as a sweetened food. Okay, in a earlier century, what happen, sugar or a honey, they are used as a sweetened food, but in modern food processing there are a number of the sweeteners are there which are used as a both bulk tradition sweetener, which is used in the amount similar to the amount of the sugar they replaced, and sometimes they also used as a sugar substitute that are many times sweetener than the sugar and are used in very small amount. Okay, so even both type of the sweeteners are present in a market. The first one is that is called a bulk sweetener. That means that it totally remove the amount of the sugar and then use it as same amount of the sugar. Suppose that you are preparing a dish A in which you are using a sugar of 2 kg. Now what happened, this sugar are replaced by a sweeteners in a same amount, that is your 2 kg. Okay, that is called a bulk sweeteners. The next is your sugar substitute. Sugar substitutes means that these sweeteners are very sweet as compared to the sugar, and they replace the sugar but in a very small amount. Suppose that in first case we use a 2 kg of sugar, but now when a sugar substitute are used, then we used only 1 gram of that sweetener. That is called a sugar substitute. High fructose syrup, which are prepared from a starch, they are commonly used instead of the sugar. Fructose sugar, this is prepared by a starch and they are commonly used in the place of the sugar, and they are generally known as a high fructose corn syrup. High fructose corn syrup, HFCS, which contain around 30% of the fructose, 35% of the glucose, and the 6% higher saccharides. Okay, this high fructose sugar syrup contain a 30% of the fructose, 35% of the glucose, and the 6% of the higher saccharides. They are also contain a 74% of as sweet as sugar. Therefore, more has to be used which achieve a same sweetness. Sugar alcohol, that is your sorbitol, mannitol, xylitol, they are also used as a sweetener. Sugar alcohol like your sorbitol, mannitol and xylitol, they are also used as a sweeteners, and they are derived of sugar which occur only in some fruits. Okay, some fruits that is your fruits and are they are manufactured by a chemical reduction of the parent sugar. Sugar alcohol have a lower calorie yield as compared to the sugar which are derived from which they are derived, and they are commonly used in the preparation of the various food product, that is your jam, sweets, which is used by a diabetic patient, and they are also considered as a safe and can be used in food in any required amount. However, an intake greater than about 20 to 50 gram per day, they cause a gastrointestinal discomfort and have a laxative effect. Okay, so fructose, which are prepared by the hydrolysis of the sucrose and the isomerization of the glucose, they are used in the manufacturing of the product, that is your candy, soft drink, and other processed food. Food. As a fructose is 124% as sweet as sucrose, and they used as a substitution of the fructose for a sugar in case of food which are permeate a reduction in the caloric value of a food. Sugar substitute that sometimes it is also called a artificial sweetener or a intense sweetener. Okay, so sugar substitutes have some other name, that is your artificial sweeteners and intense sweeteners. Intense sweeteners. They are what? They are a synthetic compound. Means that they are man-made and they are many times sweetener than the sucrose. They are commonly used in the instead of that sugar in the manufacturing of the low calorie soft drink and other food. Unlike sucrose, which is metabolized by the human body, and they are ultimately changed into the fat instead of sweeteners, and they are what? They are non-nutritive and low caloric. They provide providing a means of calorie control yet good tasting of food and beverages. They are usually do not metabolize and go through the human digestive system, but sometimes without being digest at all. They also have a added benefit of improving the palatability of the fall testing drug, helping the people who suffer from a diabetes. In market, the demand of the sugar are increases, which give result in a development of a number of the chemical. Nowadays in market, the demand of the artificial sugar, no, not artificial sugar, artificial sweeteners are increases. Okay, that's why it give a development of number of the chemicals. The major artificial sweetener which are present in a market, that is your acyl sulfame K, allicin, aspartame, cyclamate, saccharin, and sucralose. Sweetness intensity of the factories of several sweeteners which are compared with sucrose are given below. Hello, good morning, sir. Sweeteners, sweetness intensity. If we use a sucrose as a sweetener, then the sweetener intensity is 1. Fructose have sweetener intensity 1.73. Glucose have sweetener intensity 0.74. Invert sugar have 1.30. Maltose have 0.32. Lactose have 0.16. Sodium cyclamate is 35. Acesulfame K is 200, allicin is 2500, aspartame have 200, saccharin have 550, sucralose have 600 to 800, thaumatin have 3500. The first one is your acesulfame K. They are what? They are a potassium salt, and potassium salt of 6-methyl 1123 oxathiazine 43H 12-2 dioxide. This sweetener was discovered in Germany, and it is approved by our FDA in 1988. Okay, FDA approved it in 1988, and it is discovered in Germany, and it is used as a non-nutritive sweetener. The complex chemical name of this substance led to the creation of the uh, trademark common name, that is your acesulfame K. We all know that this is what? This is your complex name. That's why it give a common name that is called a acesulfame K, which is totally based upon its following relationship to a acetoacetic and sulfonic acid, and also its potassium salt nature. So the first diagram represent the acetonic acid, the second is your sulfamic acid, and the third one is your acesulfame K. Acesulfame K is 200 times sweetener than a sugar, and they They are not metabolized and thus non-caloric. It is exceptionally stable at elevated temperature encountered in baking, and they are also stable in an acidic product, that is your carbonated soft drink. It has a synergistic effect when mixed with other low calorie sweetener, that is your aspartame. uh, the common use of acesulfame K is it is used as a table uses, chewing gums, beverages, food, bakery products, confectionery, oral hygiene product, and a pharmaceuticals. The next is your alitame. Alitame, the scientific name of alitame is La aspartyl 1 and in bracket 2 comma 2 comma 4 dash tetramethyl 3 dash 3 dash thiethanol d-alanamide. They are what? They are a sweetener. It is based on upon a amino acid. It is very intense sugar, possessing a sweetening power about 2000 times that of sucrose, and they also exhibit a clean taste which is similar to a sucrose, although it is metabolized so little is needed that its caloric contribution is insignificant. Alitame is prepared from a amino acid, L-aspartic acid, and D-alamine and novel amine. This is a diagram which represents the alitame. You can see that. This is your carbon in which CH3 group are present. CH3 in one branch H group, which is again attached to a carbon, and this carbon are attached to again carbon and hydrogen, and in their branches CH3 group are attached. Then this carbon is attached to a nitrogen, and this nitrogen are attached to a hydrogen. Again, this nitrogen are attached to a carbon, double bond with O, and this is represent the alitame. The next is your aspartame. The chemical name of the aspartame is L-aspartyl L-phenylamine methyl ester. And this is a diagram which represents the aspartame. Aspartame is most widely used artificial sweetener in the world. Okay, if we talk about the aspartame, then they are what? They are a most widely used artificial sweeteners. It is proposed by a FDA in USA in 1981. They are approved by a US FDA in USA in 1981, and now it is approved for use in several other countries of the world. There is a one drawback of the aspartame, that is its instability to heat and acid. Under an acidic condition, this aspartame are slowly hydrolyzed and leads to the loss of the sweetness, chemical interaction, and microbial degradation. The shelf life of the aspartame sweeteners product is with high water content is only about 6 months. After which it breaks down into its constituent component and loses its sweetening ability. At elevated temperature, solid aspartame slowly releases the methanol so that it forms a aspartyl phenylamine and dioxopiperazine, and there is a special reaction which favor at neutral and alkaline pH value. Because of this reason, aspartame cannot be used in hot baking foods. Now the next is your cyclamate. Cyclamate are also known as a cyclohexylsulfamic acid and its calcium and sodium salt. They are discovered in 1937 in United States, and the cyclohexylsulfamic acid, they are what? They are a scientific name of cyclamine. They are 30 to 80 times sweeter than a sucrose, and they are widely used until a late 1969. After that, the cyclamate are banned because FDA have a question regarding the safety of the cyclamate. It is not banned in Canada and the European Union. Cyclamate produced by a reacting cyclohexylamide with sulfonating agent, which is followed by a reaction with sodium or calcium hydroxide to produce a cyclamate and free cyclohexylamide, which give a following reaction. This is a reaction. Next is your saccharin. Saccharin is also known as a 3-oxo-2,3-dihydro-1,2-benzoyl 1,1-dioxide. They have been available as a non-nutritive sweetener since 1900, and they are 300 to 500 times sweetener than a sucrose, and it leave a bitter metallic aftertaste, especially in case of if we use it in individual. Commercially, saccharin are usually produced by a Ramsden Falberg process according to the following reaction. This is a reaction for the production of the saccharin. Here we use a calcium and sodium salt of the saccharin, which is used as a table top sweeteners, soft drink and dessert. Saccharin is blended with the other sweeteners for improving the taste and the sweetness, and sometimes it is also combined with the sucrose so that the sugar level will be decreases in the preparation of the dyed dessert. When the manufacture of the dyed dessert take place, then we uses this saccharin with the saccharin along with the sucrose so that it will reduces the sugar level. In oral hygiene products, that is your toothpaste and the mouth washes and other pharmaceutical products, saccharin is used to mask undesirable of the other ingredients. The next is your sucralose. They are also known as a 1,6-dichloro 1,6-dideoxy fructo fluoronosyl 1,4-chloro-OCD galactopyranoside. They are what? They are a non-nutritive sweetener based on a sucrose. They are a selectively chlorinated and glycoside link between the two rings are resistant to the hydrolysis by acid or an enzyme, and they are not metabolites, and it has 400 to 800 times sweetener than of the sucrose, and is very soluble in water and stable in heat. It can be used in a food product that are baked or fried. The next is your this is a diagram which represent the sucralose. So this is all about the type of the sweeteners which are present in the market. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.